Hi students, Mr. Epperson here. This lecture is on chemical reactions and types of chemical reactions. First off, what really is a chemical reaction? Well, if we look right here, we see a group of chemicals and molecules in particular, and a group of molecules on the right. And this is called a chemical equation. Now, in a chemical equation, you have material on the left and material on the right. On the left side, we call these reactants, and on the right side, we call them products. Of course, these are just the chemical symbols. These are actually what those symbols represent. Methane represents, CH4 represents methane. O2 is representing nitrogen. CO2 is carbon dioxide, and H2O, of course, is water. This is what a chemical reaction equation looks like, and it tells us really what a chemical reaction is. Reactants turning into products. So some substances in this reaction are going to change into different substances. In this case, everything is going to change a little bit. The substances that start the reaction on the left side, again, are called reactants, and the ones that are on the right side are called the products. Now, it's really important that you see that arrow here, and we use an arrow, we don't use an equal sign in chemistry. The arrow means yields, and it symbolizes a chemical, the chemical reaction process actually occurring. So when we say that, the things on the left yield the things on the right, what we're doing is we're saying that there's a reaction process that occurs, and when that happens, those substances on the left become the substances on the right. So on the left side, they're the reactants, the ones on the right side are the products, and that the arrow tells us that everything on the left side is going to be stuff that we start with, everything on the right side is where we end with. And it's always good in a chemical reaction not to get lost and look for the arrow. So make sure you look for where that is to see what's happening. So let's do that right now. Here's our arrow, and here is the reaction, stuff on the left and stuff on the right. This is the same reaction we just saw. Again, these are the reactants and these are the products. Here's the big idea with a chemical reaction. You never make new matter. You just make new bonds with the same atoms. So when we make a reaction occur, when we start a chemical reaction, we never create new matter. We just change the matter. So that's what this first point's saying right here. Reactants and products in the chemical reaction contain the same atoms. Let's take a look, for example, in this equation. The black substance right here is the carbon. It's representing the carbon. And then we see that it gets transformed, but it reappears over here as carbon, but it gets transformed into CO2. So it starts off as CH4, which is methane, and it turns into carbon dioxide. The hydrogens, that's what the H's are right here. So these are the hydrogens. That's the carbon. The hydrogens get moved, right? They get moved to the water molecules. So they get transferred from methane, CH4, to H2O. And of course, the oxygens, these are each oxygen atoms bound together. We call that O2, or oxygen gas. And it gets moved to the water, and it gets moved to the CO2. So all those reactions, all these bonds within these reactants, I should say, get rearranged and turned into something else. So the rearrangement happens, and they change their combinations, and chemical bonds break. This is really important. There are bonds holding these together. Polar, nonpolar, whatever they are bonds connecting these together, and these new chemical bonds form in the products. So you have the breaking of bonds and the formation of new bonds. There are 5 main types of chemical reactions. As you get further in chemistry, you'll learn about more, of course. So let's learn about the 5 types. The first type, number 1, is a synthesis reaction. In a synthesis reaction, it's pretty simple. You have two elements represented here by A and B. There is no A or B element in chemistry. Well, actually, there is a B for boron, but it's not what we're talking about here. So the A just represents some random element or molecule, perhaps, and B represents another random element or molecule. And in a synthesis reaction, those two are go through a chemical reaction as shown by the arrow, and then are bonded together, and you get a substance we call AB. Here's an example: sodium and chlorine bonded together to become sodium chloride, which is salt. Sodium, this is just a metal, sodium metal. Chlorine, this is a gas. And sodium chloride is a salt, right? Really salt, the table salt that we commonly have. So decomposition is the second kind. It is basically the reverse of a synthesis reaction. So you have AB that breaks apart. There's the arrow. And now you have A and B left over. So here's a good example. Water breaking apart and forming H2 and O2. You might get a little confused by seeing these numbers here, and even some of the numbers down here, perhaps. Don't get nervous about that. We're going to learn a little bit about writing equations and a lot about putting these numbers in front. They're called coefficients. They're really important later on as we learn how to balance equations. So we're going to get into that more. All I want you to see is the letters. All I want you to notice are the letters, and that the letters get rearranged. Really, really important that you also remember some of the important ways that we symbolize chemical elements. For instance, when we look at sodium, N and little a represents sodium. That whole thing represents sodium. If we just had N on its own, that would represent nitrogen. So that's not it. And we don't write it this way, right? That's actually incorrect formatting for writing chemical equations and formulas. So make sure that when you type out or write or anything with chemical formulas that you use the uppercase, lowercase, uppercase letter always comes first, and then the lowercase comes afterwards if it's necessary. Of course, not always do you have a lowercase letter. For instance, potassium, which is K, just has uppercase K. Oxygen is just an uppercase O. This one, Cl, C and L, I like to do a little curly L because it looks a little different. This looks like an uppercase I, but remember that you always do an uppercase letter and then a lowercase letter if the chemical formula, the symbol here, is 2 letters long. So C and L, it's a lowercase L. Just make sure you always practice those correctly to keep yourself from getting confused. Okay, now we're going to get a little more complicated in terms of reactions. This is called a single replacement reaction. We're actually going to see this in the lab a little bit. Here's A, the random element, A or molecule, and then a combined group of elements and molecules called B and C. And then look what happens. A switches places with B. So A comes to bond with C, and B leaves and goes off on its own. So A and B kind of switch places. Here's an example. Potassium metal and water. When they combine, it's a rather violent reaction. Usually an explosion occurs, and the explosion usually comes from the production of hydrogen gas and a lot of energy. And so the reason that the hydrogen gas is produced is because water contains hydrogen and oxygen, H2O. And potassium, when potassium combines with water, potassium kicks out one of the hydrogen atoms and leaves behind one of them and the oxygen, and then it combines with it. And we call that KOH, potassium hydroxide. And then the hydrogen gas is left behind. So in this situation, potassium has kicked out one of the hydrogens and it's left, and this is a single replacement type of reaction. A double replacement type is shown here, and again, a little confusing, so let's follow where everything goes. A and D are combined, and then B and C are combined. And then after the equation, or the chemical reaction occurs, now A and C have combined. So A and C are now together, and D and B are now together. So they just trade partners. Often people kind of talk about square dancing or something where you have two partners together, and then people trade dancing partners in dance. So if you're familiar with that, or if that helps, it is kind of what's going on here. And here's an example where you have Na and C all bonded together, and Ag and F, that's silver and fluorine. So silver fluoride and sodium chloride bonded together, and what we're going to do is we're going to trade partners. And we always trade with, especially in an ionic bond, we always trade the non-metal and the metal of the different substances. So sodium and fluorine will get together. There they are. And chlorine and silver will get together. There they go. So they're just trading partners. The last type is called combustion, and this, of course, is just like it sounds. It happens when things combust. In particular, when the fuel is carbon-based. Okay, most fuel is carbon-based. Charcoal, candles, gasoline, your body, I mean, you name it. Whatever's burning is carbon-based. And so when carbon-based things burn, in particular, we call that combustion. And when they burn in the presence of oxygen, which is most of the time when it burns out in the open air, you always produce these two molecules, carbon dioxide and water. Okay, same thing that comes out of your car exhaust and the same thing that comes out of your mouth, because combustion reactions technically occur inside your own body as well as you do what's called aerobic respiration, which you might remember from biology. But regardless, you get a carbon-based fuel here reacting with oxygen, and the carbon and the oxygen combine to make CO2, and the hydrogen and the oxygen combine to make H2O. It's pretty difficult to predict how things are going to combine, and so really all you need to do at this point is to understand when you see a chemical reaction, what truly has taken place. Things have switched around, rearranged, but you, in the end, haven't lost any mass. It's the same amount of stuff and the same kind of thing that's coming out of the reaction as what you put into the reaction. Let's do a little bit of a quiz. Can you name the type of reaction that is shown here? Sodium plus chlorine yields sodium chloride. This is type 1, synthesis. How about this one? Iron plus copper sulfate, that's what CuSO4 stands for, yields iron sulfate and copper. Here's a hint. This is 1 unit. Even though it's multiple atoms, this is technically going to be 1 unit. And there it is again. Okay, so did you notice that iron traded places with copper, right? So the iron bonds with copper. We call this I think this is number 3, a single replacement. Here's the last one. Which type of reaction is shown with this combination? Some kind of carbon-based substance reacting with oxygen yields carbon dioxide and water. This is a combustion reaction. Combustion reaction. So that's it on types of reactions and chemical reactions in general. I hope that was helpful.